Terraform infrastructure as code. Agenda infrastructure as code systems. Terraform history. Why Terraform? Terraform lifecycle. Getting started. Basic workflow. Plan and apply. Infrastructure as code. Infrastructure as code is a practice that defines servers, networks, and services in text files instead of manual setup. If you make a mistake or break an environment, you can rebuild it from same code that created it. Almost all modern cloud platforms and teams provision infrastructure through some form of IAC, infrastructure as code. Any team running production cloud infrastructure relies on IAC for consistency. Clicking through a cloud console by hand every time doesn't scale. Manual provisioning and IAC. Manual provisioning means clicking through a cloud console or running one-off scripts to create each resource by hand. Infrastructure as code like Terraform describes the desired resources in version-controlled configuration files. Manual provisioning, cloud console clicks, one-off shell scripts, tribal knowledge. Infrastructure as code, Terraform, AWS CloudFormation, Pulumi. Problems with manual provisioning. Single point of failure. The one engineer who remembers the setup steps. Environments drift apart over time as manual changes accumulate unevenly. Hard to reproduce an identical environment for staging. Disaster recovery DR or a new region. No audit trail of what changed, when, and why. Every instruction is carried out manually and is easy to get wrong. Misses out on code reviews, version history, and GitOps style deployment. Terraform infrastructure as code. Infrastructure is declared in HashiCorp configuration language HCL configuration files and kept in a source or Git repository. Provider plugins translate that configuration into calls against AWS, Azure, GCP, and hundreds of other APIs. Terraform tracks real-world resource state and reconciles it against the declared configuration. Other similar IAC systems, AWS CloudFormation, Pulumi, Ansible, Azure Resource Manager template, ARM template, Bicep template. Terraform advantages. Works the same across nearly every cloud and on-prem provider. Speeds up provisioning with a repeatable plan and apply workflow. Shows a preview of every change before anything touches real infrastructure. Makes environments consistent and reproducible across dev, staging, and production. State tracking means Terraform knows exactly what it manages and can clean it up. Integrate seamlessly with CI/CD pipelines and version control. Everything is declarative, almost. One huge benefit is that you describe the end state, not the steps to get there. Terraform figures out the order of operation and the API calls needed to reach that state. Easy to scale infrastructure by adjusting a count or a variable, not writing new scripts. Destroying a whole environment is as simple as reversing what you declared. Sensitive values are kept out of state. where possible and can be sourced from a secrets manager. Resources and variables. Resources. A resource block declares one piece of infrastructure Terraform should create and manage. Variables. Variables let the same configuration be reused across environments with different inputs. Main.tf. A typical configuration declares the provider and the resources it should manage on that provider. Outputs.tf. Outputs surface values from your infrastructure, like an IP address, after apply completes. History. Created by Hashikov and first released in 2014 to bring code-driven provisioning to the cloud era. Built around HCL Hashikov configuration language, designed to be readable by both humans and machines. Adopted a provider plugin model, letting the community add support for hundreds of platforms and services. Terraform Cloud and Terraform Enterprise later added remote state, collaboration, and policy controls. Now, one of the most widely used infrastructure as code tools across the industry. Why Terraform? Cloud agnostic. One workflow across AWS, Azure, GCP, and more. Plan before apply. See exactly what will change before it happens. State tracking. Terraform always knows what it manages. Declarative configuration. Infrastructure as version controlled code. Massive ecosystem. Thousands of providers and community modules. Backed by HashiCorp and a large open source community. The state file, terraform.tf state, lives in the root of the working directory and records what Terraform has created. Maps every resource block to the real world object it created by ID. Should be stored remotely, example S3 Terraform Cloud, and locked for yeah, team use. Never edit the state file by hand. Always use Terraform commands. Terraform lifecycle. Author.tf files. Right. Terraform plan. Terraform apply with approval. Terraform destroy. Configuration is written, previewed with a plan, applied to real infrastructure, and eventually torn down when no longer needed. Getting started with Terraform. This leads us to the three commands that get infrastructure off the ground. Terraform init. Download providers and models and set up the working directory. Terraform plan. Preview exactly what will be created, changed, or destroyed. Terraform apply. Carry out the plan and provision the real infrastructure. Basic workflow. Author the infrastructure code in Terraform grammar. Maintain it. Create CI/CD pipeline around it. Optimize it. Plan, apply, and destroy. Some call plan, apply, and destroy Terraform's core loop. Plan is read only. It never touches real infrastructure. Apply only changes what's different from the current state. Destroy tears down everything Terraform manages in that configuration. Remote state locking keeps teams from applying conflicting changes. Supports many workflows, workspaces, modules, and remote CI/CD runners. Works the same across every supported cloud and on-prem provider. Any questions? Thank you.